Hi, Tom. Hey, you're working on one of those new 8 1/4-inch axles. Care if I watch?
Be my guest. If you're that interested, why not take it down yourself, and I'll build it back up.
All right, Tom. Say, is it much different from our other axles?
Nope. In general design, this axle is similar to our 7 1/4-inch model. The main differences are in the axle shafts and bearings, differential bearing adjusters, and the pinion bearing preload arrangement. The new axle shaft bearings have straight rollers, but there's no conventional inner race. The bearing seal lip and the bearing rollers ride directly on a journal surface, which is ground on the axle shaft. Axle shaft end play adjustment is not needed with this arrangement. Unlike the smaller model, this axle has differential bearing adjusters instead of shims. The new adjusting wrenches are needed here because adjuster side clearance is narrow. Now, in the pinion department, there's a specially shaped collapsible spacer between the pinion bearings. This new spacer eliminates adjusting shims, so you can set preload by simply tightening the companion flange nut. Ready to start on the axle, Fred?
Yep. You've got the housing cover off, so what's next?
Remove the differential pinion shaft lock screw and take out the shaft, so you can remove the locking washers that retain the axle shafts. After the pinion shaft is out, push the axle shafts inward to release the shaft retainer washers and slide the retainers out. When the C-shaped retainers are removed, you can slide the axle shafts out without removing the seals or bearings. Guide the shafts out carefully so the splines do not damage the seals.
And don't take chances on causing a leak later on by letting the shafts hang on the seals. Take the shafts completely out of the housing until you're ready for the build-up.
Hiya, Tech. Thanks for the reminder. Say, Tom, why do we check bearing end play and drive gear runout before removing the differential and gear assembly?
The end play and runout checks are part of teardown analysis and are especially useful when you're tracking down gear noise. Now, if this axle were noisy, I'd first run a gear tooth pattern. Then, if tooth contact area variations showed up on the pattern, I'd suspect excessive runout caused by end play, or by a distorted drive gear or differential case. The dial indicator tests help you to isolate the cause. On the first check, you pry the gear and case assembly sideways in both directions. If the indicator shows any end play, one or both bearing cones can be loose on the differential case hubs. Here's what happens. If a bearing cone loosens for any reason, it can cause hub wear, which results in end play. As you know, the cones are installed with a press fit, and the bearings are preloaded, so there should be no side movement. Now, assuming there's no end play, you can check to see whether drive gear runout exceeds the 5/1000ths limit. Also, we mark the point of highest runout on both the gear and the differential case flange for later reference. You see, when a gear is reusable and differential case runout is okay, you may be able to bring excessive total runout within limits if you reposition the gear on the case. Move the high runout reference marks opposite each other and recheck the runout.
And speaking of marks, don't forget to mark the differential bearing caps so you can get them back where they belong. If the caps are switched, bearing bores and adjuster threads will not match.
Okay, Tech. Now, as I recall, when the assembly is out of the carrier, you squeeze the bearing rollers in and try to turn the cones even if the indicator shows no end play.
Right, Fred. It's a double check. If worn hubs let the cones turn, you'll have to install a new differential case and bearings.
All right, Tom. You're the expert. Do these bearings pass inspection for wear and tear?
They look okay. You can reuse a bearing which has a smooth, dull gray roller path in the cup, even if the path is a bit one-sided. Of course, the rollers must also be smooth and free of flat spots. In fact, I replace bearings only if they show signs of pitting, spalling, overheating, cracks, or other damage.
Good points, Tom. Now, since I've got the pinion shaft out, I'd better remove the differential gears and thrust washers. That way the pinions won't fall out and be damaged when I remove the drive gear.
For the benefit of anyone who doesn't know, the drive gear bolts have left-hand threads. And when you remove the gear, tap it evenly around the edge with a soft face hammer so you won't damage the gear or burr the case.
According to the service manual, we check differential case runout the same way as gear runout. But here, the limit is only 3/1000ths of an inch.
Right. Just make sure there's no end play when you make the check.
Okay, I'm ready to take out the pinion.
Before you do that, check the pinion turning torque and mark it down for reference. You see, if any bearings are reused, you'll need this figure when you check or adjust preload later on. And another thing, the front bearing cone in these axles has a press fit, so you'll have to drive the pinion inward to remove it. Of course, pounding damages the bearing cup and cone, so when you remove the pinion, the whole bearing will have to be replaced.
The press fit of the front bearing cone keeps it from spinning on the pinion shaft and holds the collapsible spacer tightly in place. If the cone was free to turn, the other parts could move, and eventually the flange nut would loosen.
I get it. If there's no movement between the cones and spacer, the flange nut and the preload setting stay put. Well, the pinion and front bearing cup are out, and everything's cleaned up. What's next?
You can take out the rear bearing cup and remove the pinion depth shim. You see, if we were installing new gears and bearings, we'd start with no shim behind the cup. Incidentally, removal usually distorts the shim, so you'd better discard it.
Before you install pinion bearing cups, first make sure there are no chips, dirt particles, or burred surfaces in the bearing bores. And dress down any high spots so bearing cups can seat properly. Now it's time to see how the axle setting gauge is used, Tom.
All right, Tech. We'll need the new pinion gauge adapter set for this axle. The parts include a new arbor, gauge block, main body, spacer, and sleeve. We also use the compression sleeve, centralizing washer, and compression nut from our small axle gauge set. Now, we first use the setting gauge to seat the bearing cups in the carrier housing. Start the cups square in the bores with a soft face hammer. And to make the job easy, be sure to lube the bores, cups, and cones. And then, with the setting gauge and bearing parts aligned in the carrier, tighten the compression nut until the cups are seated firmly. While tightening the nut, be sure you also rotate the tool to protect the bearings. When the bearing cups are seated, install the gauge block so you can choose the correct pinion depth shim. To do this, you leave the setting gauge in place and turn the carrier nose down. Then attach the gauge block securely to the tool head.
Do not attach the gauge block to the tool head before installing the body of the tool in the carrier. The tool parts must be aligned with the bearings first, or the gauge block level can be incorrect.
Thank you, Tech. Now, after attaching the block, we center the new cross-bore arbor in the bearing pedestals and loosely install the bearing caps. Slip pieces of 2/1000 shim stock under the caps to assure a tight fit, and torque the bolts to 10 foot-pounds. Select a pinion depth shim that fits between the gauge block and the cross-bore arbor with a definite drag. Be sure you hold the shim flat against the block when you check the fit, or the selection may not be correct.
The shim you select will be correct only if the pinion end is marked with a 0. If the pinion has a plus mark, you'll have to use a depth shim that's thinner by the amount marked after the plus sign. And where the pinion marking is minus, you'll have to use a thicker shim. In either case, after you select a shim and build up the assembly, you'll still need a tooth contact pattern test to double-check your work. And now we're ready to install a pinion.
Installing the pinion in this axle differs slightly from most of our other models. Here, we set bearing preload by tightening the companion flange nut and partly collapsing the bearing spacer. You see, when you tighten the companion flange nut, the heavy gauge spacer compresses to permit spacer length to adjust. At the same time, the spacer maintains end pressure between the two bearing cones, so you can torque the companion flange nut to the proper tightness.
Just remember that the spacer takes a set when it compresses and must be replaced if it's collapsed too far. Preload is adjusted by tightening only. If you over-tighten and then loosen the nut, the pinion can develop end play. And now, before we go any farther, Someone had better make an end plate toward the projector to turn the record over so the show can go on.
Thank you, Tech. Now to install the pinion, we first install the selected pinion depth shim. To do this, you remove the rear bearing cup and again use the setting gauge to reseat the cup on top of the new depth shim.
Lube the parts and keep them clean when you install the pinion depth shim. If dirt or metal chips are trapped under the shim or between the shim and bearing cup, you can throw the pinion setting off.
Good point, Tech. Next, we swing the carrier nose up, put in the new front bearing cone, relube the bearing, and install the new pinion oil seal.
Say, how about bearing preload adjustment? I thought we adjusted preload before installing the oil seal.
On this axle, the seal comes first, Fred. With the new spacer, there are no preload shims to change, so there's no need to remove the companion flange or pinion once the preload is set.
That makes sense. Now, what's the story on the seal?
It's a new hydrodynamic type seal that redirects lube inward instead of simply depending on lip pressure to do the sealing job. Diagonal grooves are molded in the seal lip to wipe lube off the flange journal surface and direct it back into the housing. Using the new installer, you drive the seal into the housing until the seal flange seats. We don't need sealing compound here because a special coating on the seal's outer surface saves us the trouble.
Before you put in the pinion, inspect the journal surface of the companion flange. Replace the flange if the seal surface is rough or grooved, even if the groove is smooth. And while you're at it, make sure there are no nicks or burrs on the splines in the flange hub or on the pinion shaft. Interference friction here can raise the flange nut tightening torque higher than normal and may complicate preload adjustment.
Okay, Tech. Next, we lube the seal lip and push the flange hub into the seal. This puts the flange in position, so it'll be easier to align the splines as you install the pinion. When the flange is in place, we slip the new spacer on the pinion shaft against the rear bearing cone, relube the cup and cone, and install the assembly. Next, with the proper installing tool, seat the flange on the pinion shaft and install the flange nut and washer. Then, torque the pinion flange nut to at least 170 foot-pounds as you keep the pinion turning to seat the bearings. Stay within the torque limit at this point because over-tightening can collapse the bearing spacer too far. If this happens, you'll have to discard the spacer and front bearing and begin again. Now for proper bearing preload, pinion turning torque with a new front and a used rear bearing must be at least 10 inch-pounds over the original teardown reading. The low limit with two new bearings is 15. In either case, the high limit is 30 inch-pounds. If the torque is too low, carefully tighten the nut to produce proper preload.
Okay, Tom, that's easy to remember. But what if you're only replacing an oil seal on the car?
Well, you have to restore the original preload, so you note the pinion turning torque before loosening the flange nut. To do the job right, you'll have to remove the rear wheels and drums. Next, after the flange nut and washer are off, mark the flange and pinion to index the splines. You see, it minimizes interference friction if you reinstall the flange with the original spline indexing. After you install the new seal, tighten the flange nut to 170 foot-pounds and check the pinion turning torque. Less than 5 inch-pounds over the original reading means preload is okay, but more than 5 inch-pounds over means a new spacer and front bearing.
Don't let this preloading procedure scare you. Just be careful. Use the right tools and follow the specs. Actually, the new spacer setup is faster than changing preload shims. Tom, you'd better tell Fred about the other axle that has a collapsible spacer.
Right, Tech. Some 8 3/4 inch large stem pinion axles also use the collapsible bearing spacer. Preload adjustment procedure is the same as for the 8 1/4 inch axle, but the specs differ slightly, so you'll have to check your service manuals for the information. You can identify 8 3/4 inch axles with the collapsible bearing spacer by the numbers on the pinion section, or by the single digit near the bolt flange of the carrier housing. And while we're talking about these axles, you'll find that the factory-installed oil seals on most 69 model 8 3/4 inch axles have the flange fully seated. Some, however, have the flange positioned about 1/8 of an inch out from the housing nose. For servicing, replacement oil seals for all 69 model 8 3/4 inch axles are installed with the 1/8 inch flange clearance. You'll find that the seal installer tools are designed to position the seals properly. Just remember that these seals will be damaged if they are fully seated. Incidentally, the 8 3/4 inch axle with the collapsible bearing spacer also has other changes which require new special tools. There's an installer for differential case bearings, a spacer for the pinion depth gauge, and plates for the pinion bearing remover.
Tom's gonna talk himself hoarse if we don't give him a break. Want to take over for a while, Fred?
Sure thing, Tech. The pinion's all set, so I'll install the drive gear and put the differential gears back in. The teardown run-out check was within limits, so I can align the reference marks and put the gear back on the differential housing in its original position.
Be sure to tighten the attaching bolts evenly to the specified 55 foot-pounds. We don't want any distortion here.
Right, Tech. Differential gears and thrust washers are next. Tom, what's the reason for the shoulder on these pinion thrust washers?
It holds the washers in place so they won't slip out when you remove the pinion shaft to get at the axle shaft retainers.
Is there anything special about installing the differential assembly in the carrier?
Well, it's a good idea to provide working clearance for the adjuster wrench by positioning the adjusters inward as far as possible before you install the bearing caps.
Okay, Tom. I've got one bolt in each bearing cap finger tight, and the other is torqued to 60 foot-pounds.
Right. That way your adjustment won't creep. Next, turn the adjusters to eliminate bearing end play, but do not remove all the backlash. Now, using a dial indicator, find the point of least backlash and keep the drive gear in this position for the remaining adjustments. Next, turn both adjusters the same amount in the same direction until you get a 2 or 3 thousandths of an inch backlash indication. Then, for backlash and preload adjustment, tighten the adjuster on the tooth side of the drive gear until you get 6 to 8 thousandths of an inch minimum backlash. Then torque the bearing cap bolts to 60 foot-pounds and install the adjuster locks.
Before you go any farther, double-check your work with a tooth contact pattern test. You followed the recommended procedures for this job, so the pattern should be okay. Fred, after the pattern check, get Tom to tell you about servicing axle shaft bearings and seals on this job.
Everything's okay in the tooth pattern department, so we can remove and inspect the axle shaft bearings and seals. Here we use the new remover adapter with a slide hammer, and make sure the remover swivel bar is properly positioned, or you can ruin a bearing. Clean the bearing and carefully inspect the rollers as well as the journal surface on the axle shaft. If you find flat spots or signs of wear, both the bearing and the axle shaft must be replaced. Like the pinion oil seal, axle shaft seals are the new hydrodynamic type and work on the same general principle. Here, instead of the one-direction spiral groove, we have triangle-shaped areas which are equally effective in either direction of shaft rotation. For installation, make sure the bearing bores are clean and free of burrs. Then push in the bearings and drive in the seals with a new installer. When the tool flange contacts the axle tube, the seal is correctly positioned slightly in from the end of the tube.
Here again, when you install the axle shafts, guide the splines carefully past the seals. Push the shafts inward as far as they'll go and install the shaft retainers. If a retainer drops into the carrier housing, you'll have to get it out so it can't cause damage.
Okay, Tech. The axle shaft retainers are in. The differential pinion shaft and lock screw are back in place, and the housing cover is on. All we need now is the lube.
Be sure to use the correct lube, especially in axles with sure grip differentials. Your reference book for this session includes lube details and other service tips, so be sure to read it through. And now, it's time to bring this session to a close. Thanks to Tom and Fred, our axle servicing know-how is better than ever. Be sure to read the detailed coverage of the 8 1/4 inch axle in your service bulletins. And don't forget to check your service manuals for general axle information. See you all at the next meeting.